Hello everyone, welcome to the Weekly Space Hangout for Friday, September 30th, 2016. I'm Fraser Cain, publisher of Universe Today, and this week we've got really one gigantic story we're going to be talking about, and then a bunch of smaller stories. So obviously we're going to be talking about Elon Musk's big announcement, everybody gets to live on Mars. We're going to be talking about the end of Rosetta, spiral arms in a planet-forming disk, the first extragalactic gamma-ray binary, and more geysers on Europa. So we've actually got a ton of news. It's kind of good that we don't have a guest this week, but we do have a bunch of our regulars. So this week, we've got Yov Landsman.
Hey.
Let's see. Boom, there's Yov Landsman. We've got Morgan Renberg.
Happy Friday, everyone.
And we've got Kimberly Cartier.
Hi, Fraser. Hello, viewers.
Yay. The technology works. All right. So we've got the four of us here all together again. And, man, well, so obviously there's only really one place to start, and that is let's talk about Elon Musk's big announcement. So, Morgan, while you talk, I am going to try and sneak in some views of the presentation, the rocket system, and we'll go from there and see if we can sort of blend this all together. Ready?
This is a announcement that Musk has been hyping literally this entire year. I think it was early in January, maybe even late in December last year, that he said, this year I'm going to deliver the plan that will put humans on the surface of Mars, not to visit, but to stay. And on and off for the last 9 months, he's been teasing us with little bits of information about how progress was happening, what the goals were going to be, et cetera, and really sort of building into a frenzy anticipation for this announcement. And finally this week, it happened at an aerospace conference down in Mexico, and to a completely packed auditorium. Musk spent about an hour describing his vision for humanity in outer space, and then answering some questions from reporters as well as members of the audience. And there's a whole lot to say here. I think there's sort of three groupings that we should look at. The first is, well, what did he say? What's the plan? And then, is this plan feasible? Can we do it? Can we afford it? And then finally, what didn't he say? Because there were a couple of things he didn't say that loom almost as large as the things that he did say. And that may ultimately govern whether or not this plan happens. But first, what are we talking about? Well, if you missed the news this week and really all of his teasing going back for the rest of the year, this week, Elon Musk, the CEO of SpaceX, introduced what's now being called the Interplanetary Transport System. Previously, we've talked about it as the Mars Colonial Transport or other names like that. It's this rocket system, not just a rocket, but a rocket and a spaceship and fueling capabilities, and all the stuff necessary to send large amounts of people and equipment basically anywhere in the solar system. And we're really talking about truly enormous amounts of equipment here, because the rocket that forms the core of the interplanetary transport system is more than twice as powerful as the Saturn V that put the Apollo astronauts on the surface of the moon. And in some respects, it's even 3 or 4 times as powerful. So we're talking about something that is not just one, but several classes above anything that's been launched in the last few decades, or really even in the history of spaceflight. Not only is this rocket exceptionally powerful, it's also fully reusable. And parts of this rocket system are designed to be used as many as 1,000 times before they need to be scrapped and a new one built. And it's all of these pieces coming together. The goal is to make the cost as low as possible. And that's why there's this emphasis on being not just partially reusable like the Falcon 9 is, but completely, fully reusable. No part other than the burned up rocket fuel has to be replenished. And one of the ways that he gets the cost down as low as he's claiming it might be is by launching the spaceship basically empty of fuel. So he puts just enough fuel in the spaceship to perform some sort of emergency return to Earth, and then launches it up into Earth orbit. And then using these refueling or these reusable capabilities is then able to shuttle up loads of fuel to the spaceship, pump that fuel in, kind of like mid-air refueling for military planes here on Earth, until the ship is filled with fuel, and then launch that to Mars. And that's sort of opposite the Apollo approach. The Apollo approach was put everything you need to go on one big rocket, blast it off all at one time. And Musk is saying, well, if you want to go to Mars with a reasonable number of people and a reasonable amount of equipment, that's just impossible. Even with a rocket that's 2 or 3 or 4 times more powerful than the Saturn V, you just can't do it. So instead, we're going to build this rocket to be very cheap to fly over and over again. We're going to send stuff up piece by piece, assemble it basically in orbit, and leave from there. And the reason it has to be so big is because he wants to send a lot of people. You know, we sent 2 people to the surface of the moon each time the Apollo missions went, and a total crew of 3. And Musk is targeting to send as many as as few as 100 people and as many as 200 people per trip of this interplanetary transport system. Yeah. Now, you have to go back. You have to add up all the astronauts that have been on the space station in the last couple of decades to get up to 100 people that have been in space. Period. And he says, well, we need to send 100 to 200 people at a time to Mars. And we need to do it quickly, in as little as 80 days. Yeah. And that is substantially 2 or 3 or 4 times shorter than a trip to Mars typically takes today. So we need more people with more equipment getting to Mars faster. This is the need for this truly enormous rocket system. But sort of looming down on all of this is that if you're going to get people to go, it's got to be affordable. And if you're listening to this at home, I'm putting some pretty heavy air quotes around affordable right now, because his goal is to send people to Mars with a ticket price of something in the neighborhood of $100,000 US. His sort of tagline is that if you were to buy a house in the United States, why not buy that house on Mars instead? And while that is a lot of money, it's incredibly cheap compared to previous spaceflight. It costs about $1 million a day to keep the ISS astronauts alive in the space station.
Yeah, he said that the current price, the estimate to send a human to Mars is about $10 billion right now. So to drop that price down from $10 billion to 200,000 or even 100,000 is a pretty big drop.
Yeah, it really is. Speaking of sort of $10 billion, that's what he thinks this whole system is going to cost. He says the rocket, the shuttle, the fueling stations, all that stuff is going to cost around $10 billion to build. And then they can start sending stuff and ultimately people to Mars, maybe even within a decade, if technology was the only hurdle that he needed to cross.
Not within a decade. 2024 is when the first one of these things is going to go. It's crazy.
Yeah, and so another way that he's going to work to save cost is that once the astronauts reach Mars, they're going to build basically plants, factories that are going to produce all the fuel on Mars that would be necessary for any return trips. So he sort of flirted in the past with the idea that if you go on this trip, it's a one-way journey and there's no coming back. And he walked that back this week and said, no, it will be possible for people who go to Mars to come back to planet Earth. They're just going to have to make the fuel on Mars to enable that to actually happen.
But there's going to be all these reusable rockets piling up on the surface of Mars that if you want a return trip, take one of those.
Right. And there was one more big number that he slipped into this hour-long presentation. And that was his assertion that he thinks for a colony on Mars to be self-sustaining, that it would need to have 1 million inhabitants. That's the size of a medium-sized city on Earth today. And 1 million inhabitants is an eye-watering number for an enterprise in which we haven't ever even sent 1,000 people to space. And now we need 1 million people to make this colony basically worthwhile. And he thinks that that could take as few as 40 or as many as 100 years to accomplish. And until they're self-sustaining over that 40 to 100-year span, they're going to be dependent on Earth continuing to send needed supplies to sustain them. And so starting this process is basically putting a large indefinite burden on those of us who remain behind to continue supporting them and to continue funding the sending of hundreds of thousands of people to fill out this large settlement.
All right. So, I mean, I can hear the dripping skepticism in your voice, Morgan, and so I know that you are intrigued, but at the same time you have questions. So, I guess let's start on the positive side first. What's the stuff that you thought was pretty great and kind of went past your expectations?
So the best part of this, and Musk and SpaceX deserve all the credit in the world for this, is just the audacity of the idea. The audacity to say this is something that we can do and this is how we would do it if we wanted to do it is something that no one else in the space exploration industry is doing today. This is what he presented today was far more comprehensive than anything NASA has presented, far more comprehensive than anything any of his competitors have presented, even far more comprehensive than what we've seen sort of pop up in the scientific literature. And it wasn't just sort of a pie in the sky, wouldn't it be great if this is what we could do? It was, this is step one, this is step two, this is step three. And he even showed pictures during the presentations of, here's our engineering prototype for one of the fuel tanks for this big rocket. This is how we're testing it. We've invested this amount of money so far into trialing this and trialing that. This is, make no mistake, no matter what we say next, this is the most concrete, most believable plan for getting humans to Mars rapidly. So that's very positive. On the negative side is the fact that he's basically planning out this whole system on technology that we don't even yet know works. And so I highlighted the fact that to be cost effective, parts of this rocket system need to fly 1,000 times before they have to be replaced. Now, they've launched and landed 5, I think now, Falcon 9 rockets. They've never relaunched one of them. They have no idea how much effort it's going to take to reliably relaunch a rocket one time. It's never happened. And now we've jumped from not yet having launched once to saying, well, our system's going to be reliable 1,000 times over. And if you want to use it 1,000 times, in engineering terms, that means it's got to be reliable to 2,000 times or 3,000 times in order for it to be safe and cost effective and all sorts of things. And so that is, a tremendous leap to take based off of technology that hasn't yet functioned. Another example would be the whole plan for landing this spaceship on Mars is to do what's called propulsive landing. It's where you basically what they did to land on the moon. You fire your rockets to slow down as you come through the Martian atmosphere and you touch down nice and gently on the surface. And this is the plan for the second generation of the Dragon capsule. The Red Dragon, going to go to Mars. It's going to land propulsively. It's going to deploy maybe some basic scientific payloads. That hasn't launched yet. In fact, parts of it can't even be tested in Earth's atmosphere because of the different pressures and gravities and forces and whatnot. And so to say you're going to land 100 or 200 people with giant propulsive rockets when you haven't landed anything propulsively yet other than a couple of spent rocket stages, that's a huge leap to make. Doesn't mean it's impossible, but it probably does mean that trying to do this in 8 years or for $10 billion is not a plausible figure. It's not a plausible timeline. And SpaceX is not exactly famous for sticking to their stated timelines. And I said there was a category of things in this presentation that he didn't mention. And two of the things he didn't mention, one of them was that in the last 15 months, 2 Falcon 9s have exploded. And here's a vastly simpler rocket trying to accomplish a vastly simpler task. And they're seeing failure rates that are higher than their competitors. That's not good. Moreover, their number one customer needs to have belief that it's going to work if they're going to keep funding them. SpaceX might launch commercial satellites and weather satellites and what have you, but NASA is their largest, first, and most important customer. And if NASA thinks that SpaceX is losing focus on their mission to deliver cargo to the International Space Station, especially with a plan that must be embarrassing to members of the space agency who don't have a plan this comprehensive themselves, then they might start to reduce their support financially of SpaceX. And he also didn't talk about the Falcon Heavy. He's already introduced a rocket before the last rocket he introduced has even flown. And that was supposed to fly in the second half of this year. And although he didn't mention it, he put up a timeline slide for SpaceX's activities, and that's now slated to fly sometime in 2017 instead of 2016.
Yeah, it was supposed to fly in 2016, and now it's saying it's going to fly in 2017.
Yeah, and it's a rocket much closer in size to the Falcon 9 than to this new interplanetary transport system. So again, it's trying to learn to run before you've even learned to crawl. And it's great to have the idea of running, because obviously that's going to turn out to be a really important thing in your future. But to say, oh, I'm going to run, as a 4-month-old is not a plausible thing to do. And I couldn't be happier that Musk is out there selling this, talking about this, getting people excited about this. I couldn't be more excited to see the direction in which it goes, but I couldn't also be more cautious about when this is going to happen and how ultimately they're going to pay for it and who ultimately is going to go. Because I think we're talking about something that isn't going to happen in 2024, but I'm excited to see how much progress have we made in 2024? Because I can bet you SpaceX will have made a lot more progress by then than NASA will have.
Kimberly, you've got a comment.
So I think that one thing that hasn't been mentioned yet are all of the issues. Once we have these 1 million people on Mars, there are a whole host of socioeconomic issues that we have not even touched on yet, such as reproduction on Mars. How does that work? Or does it work? Are there medical complications? Or what about disease spread in such a closed loop system, as someone in the comments put it? As well, who is in charge? What form of government do they have? What are the ties to Earth? Laws, schools, taxes, etc. All of the things that we mere Earthlings have to deal with. How does that translate to Mars? How independent or not would this population be? And I think that those are some major things that they're going to have to hash out before they start sending people there.
But, will they have elections?
Well, I think, the questions at the end were cringeworthy from the audience. But one of the questions sort of about that radiation question, and I think it sort of segued into what Musk's take on this really is that if he can deliver you a flight to Mars, a return trip to Mars for $100,000 or for $200,000, he can probably get a lineup of people around the block willing to pay that money, knowing they can go to Mars for a couple of years or stay forever and come back. And I think his take, this is the impression I got, is that what you do on Mars is not his problem. That he is the train conductor, he is the taxi driver, and if he takes you to your party and how drunk you get at that party, he is the taxi driver. He doesn't care. So I think that is the way that he's setting it up, and that was the way it really felt like he was sidestepping those questions. Is listen, anybody want to go to Mars for $100,000? Everyone put up your hand. Rocket's over there. We've tested that it works. Get on board. We'll drop you on Mars. What you do then is entirely up to you. That was my impression, and I think that sidesteps the question that a lot of people at NASA and ESA and all these people they're dealing with, is just like, what about who do we elect and what are the social economic politics and all this kind of stuff. And I think that was the impression. I think that's a good stance for SpaceX to take, which is just
sure. But I mean, if they want to be realistic, if they want their 1 million people estimate to be actually realistic as a self-sustaining society, there are so many other things you have to consider in order to actually make it self-sustaining. You need doctors, you need police people, you need engineers, you need a wide variety of different occupations and demographics in order to actually make it self-sustaining. So on the one hand,
there are laws on Earth today that govern what we can and can't do on other planets. Mars is covered under the planetary protection. So we can't send living things to Mars legally today. So if they tried to do that tomorrow, the FAA would revoke their ability to launch rockets. They'd say, no, you can't do that. There's a treaty between all the nations of the world that no one can own a piece of another world. So what happens when the second flight of people shows up, lands next to the first and says, oh, you can't own that space habitat you just built. I'm going to take it. There are questions here, as Kimberly has highlighted, that go far beyond the technical engineering capabilities. And I think that sorting those out may take longer than the actual technical ability to get to the surface of Mars safely.
But are these Musk's problem?
They are if you want people to pay him to do this. He spends $10 billion. He has a rocket that no one's allowed to ride in. Oops. He ought to be working now to figure out how he's going to get customers at the same time he's working on how he's going to deliver them.
Now, what do you think about this as just an overall method of transporting equipment and people and materials just around the solar system? Just this idea of a relatively inexpensive transportation system. He showed pictures of Europa or Enceladus, people walking around the surface there. What do you think about that?
Yeah, again, if it works, it's the future. Clearly, you can send larger payloads to space if you can separate the fuel from the spacecraft. Even with like a NASA mission to Mars or a mission to Jupiter, more than half sometimes of the spacecraft is made up with just the fuel needed to get it there and to slow it down into atmosphere. And so if you can break those into two shipments and you can then make each one twice as big, and it only costs you, $1 million or whatever to make a second trip up there with this reusable rocket. That's a huge, tremendous benefit to our ability to explore the solar system. But that relies on the rapid relaunch cadence of these rockets. And that's something that, honestly, Blue Origin has demonstrated better so far than SpaceX has. They may have a much smaller rocket than SpaceX, but they've launched it and landed it and launched it 2 weeks later and landed it and launched it 2 weeks later and landed it. They're showing that that's doable, at least on that kind of timescale. Musk is saying he's going to launch it, land it, 10 minutes later, launch it again full of fuel. That technology doesn't exist yet, and SpaceX are not necessarily at the forefront of demonstrating that it's possible to do that.
It is kind of funny that he did sort of skip an entirely intermediate step, which is to take that whole concept of this reusable booster, scale it up a little bit or somehow make it based on the Falcon 9, have some kind of upper stage that is also reusable, be it, the next version of the Dragon, but maybe only carries 4 people to orbit. Or, someone is saying in the chat, something that's suborbital. If he can crack that of reusable bottom stage, reusable upper stage, that single-handedly just tears apart the existing launch market in an entirely new way. It's interesting to me that he went straight to, now let's build something that we could we could hide a Saturn V inside that is, that carries 100 people. Like, where's the one that carries 4 people? That alone would be an absolute revolution in this field.
Well, and that's the danger, I think, that he faces here. And it's the idea from his largest launch customers that they're no longer his priority. That the Falcon 9, with its failures, is, been backburnered. And why not then take those launches to Blue Origin and say, you're also pursuing this low-cost reusable rocket technology. If you guarantee us that will be your primary focus for the next 15 years, then we'll shift all of that launch capability over to you. And if they do that, the bottom falls out of SpaceX. because you can't throw up trip to Mars on Kickstarter and hope to raise $10 billion. If governments and large corporations don't have the belief that you're going to follow through and not move on to the next shiniest target, then they're not going to invest the tens, hundreds of millions of dollars necessary to even make this technology possible. And I think that now that he's unveiled this plan, he needs to go on kind of a PR tour to reassure the rest of the spaceflight community that they're investigating the Falcon 9 launch errors and they understand what's happening, and that somehow the research they're doing here is going to lead to safer and cheaper and more reliable Falcon 9 launches and all of that. And because if he loses that business, he loses the company. And right now he's behaving pretty cavalierly with what is his core business. And I think as exciting as that is, that's a real warning sign for the short term, for the next 3 to 5 years. He needs that money, and he's got to put the effort in to keep it.
Right. And as you said, there's a lot of exciting things that are happening with Blue Origin, with the new Glenn rocket and potentially the new Armstrong rocket. And really Jeff Bezos' attitude about this, which is that Earth is the best place to live. By all means, let's go and put some people on Mars and let's explore. But really, let's try and get heavy industry off the Earth. Let's double down on space exploration, but in a more measured way. So I think you're right. If it was just Musk, if it was just SpaceX alone, and they had created this dramatic new method for getting into space, they would have time to work out the bugs. But in this case, because there is competition now nipping at their heels, which is awesome to think about, that there are all of these, not only what's happening with Blue Origin, but also I'm sure United Launch Alliance and all these people are thinking about ways they can reusify their rocket systems. That it's going to be a whole new marketplace. And so, if you are bleeding off a ton of your revenue into this, into this personal mission, it's going to make the company less competitive against the competitors that don't have those same kinds of plans.
I think it's all about a vision. What Musk is saying, that this is a long-term vision, and all of the problems that Morgan discussed are technological and engineering problems. They're achievable, it's doable, and it can be done in our lifetime, in the short years to come. And this is the main point. I wonder what people thought about the promise of President Kennedy in the early 60s, because people that will go to the moon it was impossible. There weren't even rockets that are comparable to what was needed. Nobody knew how to do it. There weren't the right fuels, the right engines. It was a complete new thing, and this is what visions are made of. So.
There's a great question in the chat, Morgan, about from Adam Smith. But will building and running a rocket fuel factory on Mars be as simple as Elon Musk has implied? Do we know that they can build rocket fuel on Mars yet?
So I'm going to tackle Yoav's comment first. I agree. I think the vision here is wonderful, and it's something that we've so badly needed. But I think it's dangerous to try and draw too close a comparison with Apollo. Because in the Apollo program, you had, the world's richest country, essentially at war with the world's second richest country, saying we will spend any amount of money to do this, and we'll expend any amount of resources. Ultimately, when the Apollo 11 astronauts stepped foot on the moon, there were nearly 500,000 U.S. federal employees working on the Apollo project. They spent $200 billion. That kind of money doesn't exist for Musk's plan. That kind of personnel doesn't exist for Musk's plan. And today we have a lot of better technology, and I think we can do things more cheaply. But he's blazing a different path. And I am so happy that he's blazing that path. But I think that, as any salesman would do, he's underselling the difficulties and overselling the short-term promises that we might have.
So really, it's just like, we don't want to have our hearts broken.
Yeah, I think that's a fair way to put it. With respect to the question about fuel, the chemical reactions to create rocket fuel from basic atmospheric components are actually pretty simple. You basically just get those gases and add energy, and out comes water and oxygen and rocket fuel. And so I don't think, it's going to be a technical challenge, but I don't think it's a challenge any larger than some of the others he's outlined. And this is certainly something that has been considered in the academic literature for decades. And so a lot of people have thought about how to make this function practically on the surface of Mars. And so I think by the time we're ready to start landing people, especially if we have people there capable of shoveling Martian soil into it to show that it works, that won't be such a big deal. In the past, we've thought a lot about how to roboticize this sort of thing. But if you have people there, it can totally change your outlook.
Right. Well, and I know that NASA is planning. There's the Mars, or is it ESA? The In situ Mars mission. So they're going to be testing out some of these technologies about what kinds of resources can you manufacture on the surface of Mars. Can you, pull the water right out of the atmosphere, combine it with the carbon dioxide from the atmosphere and use this to create methane? Can you use this to create just, drinkable water? Can you use this to, liquid hydrogen, liquid oxygen? So a lot of those raw materials are there. The question is, can you pull them right out of the atmosphere? Do you have to find some reservoir of water? If you go to the North Pole, do you pull that stuff out of the soil? So these are the questions.
This stuff's more testable on Earth than a lot of parts of this.
Yeah.
We know the composition of the Mars atmosphere. We know reasonably well the composition of the Martian soil. So to a better degree than a lot of stuff, we can simulate the surface conditions on Mars here on Earth and try out these reactions and see what works. And then we can test permutations and see, well, how robust is this reaction? If it turns out there's more nickel in the Martian atmosphere or in the Martian soil than we expected, does that mess it up? If it turns out there's more of this or more of that, I think this is a problem that can probably be pretty effectively solved here on Earth before we get there, unlike a lot of the other problems that they'll be facing.
And I think the biggest unsolved question, and I think Kimberly brought it up, which is that we don't know if a human being can survive for any long period of time on the 38% gravity that they have on the surface of Mars than compared to what we have on Earth. We don't know if that is lethal to human beings over a couple of years' time, that if children are born into that kind of gravity, if they'll be able to survive. And that is like, if that doesn't work, then you will never be able to go to Mars for any longer than a quick trip the way we go to space. That Mars will be off limits as a place for people to live any long term. And we don't actually know the answer to that question. It would be handy to know that before we send hundreds of thousands of people.
Absolutely.
Yeah. Cool. Okay. Let's move on then. This is pretty cool though. Boy, we could literally talk about this forever. And so I guess, if I was to sum it up, Elon Musk, please don't break our hearts. Build this thing.
That's a great title. Stay
to your schedule. And yeah, is that the title for this week's episode? Please, Elon, don't break our hearts. And you said the things that we as super space nerds have been hoping for all our lives. For someone to say, we're going to space, we're going to make it happen, human beings are going to become an interplanetary civilization, and now you did it, and so now don't break our hearts. All right, let's move on. Kimberly.
Yes.
Let us talk about hidden spiral arms in a planet-forming disk. A news story as big as Elon Musk's announcement.
Well, thanks for that pressure. So maybe not quite as big. Bigger in physical scale, maybe. So I've mentioned many times, we've found thousands of exoplanets of all shapes and sizes and all sorts of orbits. But one of the big remaining mysteries with exoplanets is what exactly is their formation process? What are all of the intricate details that all need to fall into place to make this wide variety of exoplanets that we see? One of the biggest issues is, how do you make planets at large orbits where the protoplanetary disk is a lot thinner, there's a lot less material to work with, and because there's less material, the material that's there is susceptible to gravitational instabilities. So how do you make planets there, and are we just wildly guessing of the gravitational interactions that could happen in these disks? Well, turns out we're actually on the right track in thinking about our planet formation theories, because we've now detected with ALMA a hidden in terms of it's not visible in the visible or infrared, but when we look at it with ALMA in the millimeter and submillimeter ranges, we see deep into the protoplanetary disk, and we see a spiral pattern in the protoplanetary disk around the star Elias 2-27, which is a star-forming region near the constellation Ophiuchus. And when we peer into this disk and we see a spiral structure, it looks remarkably similar to the types of spiral structures we see in galaxies in the Milky Way and Andromeda and things like that, which we know are caused by gravitational pressure waves traveling through material. So we've seen very subtle spiral patterns, say, on the surfaces of these protoplanetary disks, but planets don't form on the surfaces of disks. They form deep in the interiors where we haven't been able to see before. But now that we see the spiral pattern on the interior of the disk, we know that we're on the right track in thinking about all of the gravitational interactions that happen in these planet-forming regions.
So in the Milky Way, right? These density waves that are moving through the spiral arms. This is the place where you get the star formation. Now, the spiral arms that we see, those aren't like actual arms that are turning. Those are just regions of higher density that the stars are passing into, and you get increased star formation. So is then the connection here that maybe this is where you get planetary formation? Is there some function to these spiral arms in these planetary disks? I've got the picture. I'm just going to put this up for people. It really does look like a galaxy.
It really does. But this is actually just a star with a protoplanetary disk surrounding it. And if you actually look really closely at that image, you do see a very narrow gap where a planet is forming. But I think what's notable is that the planet is forming interior to where you actually see the spiral structure. So in terms of scale on that image, that very narrow gap where the planet is forming is at a distance that's just larger than Neptune's orbit, and those spiral arms actually extend about twice that distance. So what we think is actually happening is that the gravitational pressure waves that are forming the spiral arms are actually inhibiting planet formation out past where that planetary gap is. We think that the pressure waves actually disturbing the material so it can't coalesce and form a planet. Right.
Okay. That's still the picture is absolutely stunning. I'm just going to go back to look at it again. Is. And this is the ALMA, right? The Atacama.
So this is ALMA. ALMA has become famous for producing these incredibly high quality, just stunning images, these close-ups of planet-forming regions, and actually seeing the planet formation at different stages and in different regions where the planets are forming. And it's a spectacular thing that we've never been able to observe before.
Yeah, absolutely fantastic. Well, thanks a lot. So I think I'm going to go next to Yov. We're going to talk about, you put a story up this week, but also how's your space flight going after the SpaceX disaster? You gave us an update a couple of weeks back. I just want to know how things are going there.
Well, it's not working that fast. We need more weeks, I guess. Because it's government issues are working slow.
But is there going to be a replacement? Is insurance going to cover the cost of your satellite?
I'm sure there will be a replacement. I'm sure.
All right. Well,
it's just a matter of time.
Yeah. Okay. I mean, we're thinking of you.
Thank you very much.
All right. So let's go on. Let's talk about the end of Rosetta.
Yes,
Sad
another
trombone.
story about heartbreaking thing. It all it was about 8 hours ago. The Rosetta mission ended after 12 years in space, 10 in the journey towards the target, which is comet 67P Churyumov-Gerasimenko, and 2 years following its nucleus in a pseudo orbit some tens of kilometers away from it. And one of the most intense and daring moments of the mission was, of course, the lander Philae that was detached from Rosetta and attempted landing on the surface of the nucleus. And the result was actually bouncing a couple of times on the surface until it became stationary in a site which is mostly in the shadows, which was not very good. But in the end, both Philae and Rosetta have fulfilled their mission objectives, I think, far and beyond, collecting data for decades of scientific research. And now came the time to end the mission, and mostly because the spacecraft aged a lot from the space environment and the dust of the comet itself. And ESA, the European Space Agency, decided to end the mission by landing the spacecraft on the surface too, which is a good practice because the other option is just to let it to keep an orbit around the sun, and without control it might collide with something and we won't know it.
I'm going to put up a picture of the spacecraft, just the picture that ESA put up of it 1.2 kilometers above the surface of the comet. And, this is a level of detail that we never got a chance to see during the mission itself. Now, of course, this is one of the last things that it was able to see before actually landing, and I'm using Morgan air quotes here, on the surface.
It actually did science all the way down. It was incredible.
And once again, it's funny how these things are never built to land on asteroids, and yet they keep landing them on asteroids. Right? That was the end of. I'm trying to think the other mission.
The other mission was near Schumacher.
Yeah, and it landed on the surface as well. Once again, no landing gear.
On Eros in 2001.
Yeah, you'd think there'd be some value to actually being on the surface of the asteroid. That's where you're stuck.
Yes, but they said that when Rosetta touched the ground, it was automatically passivated, which means that the transmitter turned off and all the systems turned off also. And it's just, and by the way, the landing spot is not very, very far from the landing spot of Philae, which is kind of lovely, I think. And they both will stay on the comet nucleus practically forever.
Yeah.
And I think in addition to that, ESA made a great thing investing in outreach and public relations of the mission. I think we all got to know and love the cartoon characters. I have my own here.
Is that like a stuffy? Is it actually like a?
It's a plush.
Oh, that's adorable. Yes, I'm putting up the picture, the last drawing they put up for the mission. So it's saying mission complete, and I guess they've got Rosetta's got a little book that it's going to start reading.
Yeah, and the whole mission was very inspiring and technological, ambitious, and it was great to see missions like that. It was, I think, in public relations scope, it was at least as what NASA did with Curiosity, and we want to see more missions like that.
Yeah, absolutely. Good. Well, I think as well, it was a really great example of just how to communicate with the public. Like the folks at the European Space Agency did a great job of reaching out to the public, of putting out all that information, of personalizing, anthropomorphizing the mission itself, and we were able to really kind of share. And it made it really interesting the way they did a lot of the live stream stuff as it went to its insertion orbit, and then the hunt for Philae and all that. And so I think they did a great job of both managing the mission and helping us bring all the science coming out of it. So I think all planetary astronomers are looking forward to years and years and years of data to study and understand everything they can about comets. So goodbye, Rosetta. Thanks for everything. All right, Morgan, let's move on to your next story.
Yeah, we reported this story for the first time a couple of years ago, and it was the potential Hubble detection of a water plume coming off the surface of Europa. And this was announced initially back in 2013 with data from 2012 that showed this sort of very small fuzzy smudge on the edge of an ultraviolet image of Jupiter's moon Europa taken by the Hubble Space Telescope.
Yep.
This is the most powerful observation that we can make of Europa today prior to sending a spacecraft out to check it out, is to use the Hubble Space Telescope. They did that in 2012. They got this tiny little blip that appeared to maybe kind of be water above the surface of Europa. And there was a lot of debate about whether this was real or not real, because they made several more observations and they never saw it again. And for a while, we sort of put it to rest. But I'm back today to tell you that we've swung back towards seeing it again. And this is analysis that was unveiled this week, but based on data that was taken back in 2014. And they looked over the course of like a year, 10 times at Europa using the Hubble Space Telescope. And of those 10 times, 3 times in 3 consecutive months early in 2014, they saw another water signal coming from Europa. And so this is, add that to the one we had before, we now have 4 independent observations of a water signal at Europa. And so this is I think you should look at this and be cautiously optimistic that there are water geysers at Europa, just like at Enceladus. The researchers are saying that this seems to be valid from sort of a statistics standpoint, but there's always the possibility that there's something about the surface of Europa we don't understand. There could be some very subtle aspect of the Hubble Space Telescope instrument systems that only sort of appears in the viewing configuration necessary to look at Europa. But we shouldn't be immediately put off by the idea that we saw it and then we didn't see it, and we saw it and we don't see it, because we have precedent for that. Cassini's been observing the geysers on Enceladus now for more than a decade. And as best we can tell, those actually are constant, at least over the time period that Cassini's been in orbit. They have always been putting material out in space. But the amount of material that it emits through those geysers changes by a lot. It can be sometimes more than a factor of 2 from its lowest to its highest point just in the course of one orbit. And so there's a lot of evidence to suggest that there are factors that can affect how active these geyser processes are. And on Enceladus, it's strong enough that you're always getting something. But it's quite plausible that on Europa, these processes are sort of much more borderline, and that when it's favorable, you get geysers. When it's not favorable, you don't. But any geyser at all is a really big deal, because if that geyser, like on Enceladus, is connected to the ocean underneath Europa, that's huge. That's a connection between the surface and the ocean underneath. And it's a connection between all the organic matter that we think is on the surface and that water underneath that could provide a habitat for life.
Right. So when we talk about all of these crazy missions to try and like send a submarine to Europa, and you've got to burrow down through this incredibly thick ice sheet to try and sample the water underneath. If these geysers are for real, Europa's doing the hard work for us. It's bringing that material to the surface.
It might even be, and it even enables an easier process. It's probably still going to be tricky to go down a geyser and get into the ocean, but this geyser's throwing the ocean up right at us. And so if you just plop down next to the geyser and stick out your tongue, you're going to get a sense of what's in that ocean, what chemicals are in it, what's the temperature, what's the salinity, do we see organic compounds, do we see evidence for life? If there aren't geysers, those questions are probably 100 years away from being answered. If there are geysers, those questions could be answered sooner rather than later. And that's why further confirmation of the presence of water on Europa is such a big deal.
Yeah, this is pretty exciting. And when you think about the fact that there is a mission being sent to Europa, it's in the works right now, and we'll go there. Good timing for us to study this even better.
Yeah, they're still thinking about if they have to have a lander to go to the surface, as Congress has mandated, where do you send that lander? And if you have geysers,
you go to the geysers.
Direction to send your lander towards, and a heck of a better reason to have a lander than previously we might have had.
And I should let people know that we're actually going to be talking about geysers across the solar system on Astronomy Cast, which is going to be, we're going to be starting the live stream of Astronomy Cast right after this. But if you haven't already caught that, then you can catch the Astronomy Cast in our regular Astronomy Cast feed. We'll be talking all about geysers, especially about what's going on in Europa, but also just how they work on Earth and where they might also be in the solar system. Awesome. Okay, great news. Let's move on to one last story from Kimberly talking about extragalactic gamma ray binary.
Yeah, so NASA's Fermi Gamma Ray Space Telescope managed to detect one of the more rare things that we've ever seen in our own galaxy, and they detected it in the Large Magellanic Cloud, which is a dwarf galaxy in orbit around our own. And not only did they detect the first extragalactic version of this particular object, but it's also the brightest, the most luminous of these objects that we've ever detected. So this source is called LMCP3. It is a gamma ray binary system, which consists of a very high mass star, about 25 to 40 times the mass of the sun, which is in a binary system with a compact stellar remnant, either a neutron star or a black hole. And they were able to detect it because of a very high energy process that interaction that's happening between this compact source and the star. I'm
playing a video, by the way. So in fact,
Gotcha.
what you're describing is working perfectly to what's going on in the video. So please continue.
Right. So in the video you're watching, the compact source is purple and the high mass star is the bright blue one. And as the compact source orbits around the high mass star, it flings very high energy electrons at the star. These electrons interact with the very hot radiation coming off the star, and that interaction gives off periodic bursts of gamma radiation. And this is probably the most high energy interaction we've ever been able to see in space. And like I said, we've only found 5 of these objects in the Milky Way, and this is the first one ever detected in another galaxy. Just because the process is so rare and the system configuration is so rare and only lasts for a very short time. What I also think is very cool about this particular discovery is that while it was discovered by NASA's Fermi telescope, it was confirmed by telescopes all around the world, including the Swift telescope, Chandra, the Australian Telescope Compact Array, the Southern Astrophysical Research Telescope, the South African Astronomical Observatory. All over the world, they were able to detect this extragalactic source in gamma ray, X-ray, visible, radio, this incredible multinational collaboration to confirm this incredibly rare object in another galaxy. And this gives us a glimpse into some of the most high energy processes that can happen in a star system, which is an incredibly rare and exciting opportunity.
It's funny, it doesn't surprise me that it was found in the Large Magellanic Cloud, right, in the Tarantula Nebula. That's where all the big crazy stuff happens, all the largest stars, the biggest supernovae, remnants,
Yeah,
I
this
expect.
this is a ginormous supernova remnant with one of the largest stars we've ever detected and the most luminous gamma ray source that we've ever detected. The Large Magellanic Cloud is quite exciting.
Yeah, and for the folks in the southern hemisphere, pretty to look at. Unfortunately, for the rest of us in the northern hemisphere, we can't even see
We
it.
miss out.
Yeah.
I mean,
sucks.
we get a lot of other things, but a lot of the excitement happens in the southern sky, I have to say.
Yeah. Yeah. I mean, they can see Alpha Centauri. They can see the Omega cluster.
Yeah, you get the closest exoplanet, you get this extragalactic gamma ray source, you get
The Magellanic Clouds.
Magellanic Clouds,
Yeah.
galaxy superclusters, whatever.
Yeah. So not
We
there.
have Kepler, I suppose, but
All right, so let's see. So we've got a couple of questions here. Let's see. I had a couple of questions here. I'll see if more come up. A good question comes from maybe Morgan. I don't know if this is sort of in your field, but Danny Jaber wonders why bacteria hasn't dominated the universe yet.
Well, I could say that bacteria certainly have dominated the Earth.
Yes.
We may not be able to see them, but numerically they far outweigh you and I in both a physical, literal sense and metaphorically. It's quite possible that bacteria do dominate the universe, and that's why we don't hear from alien species, because as best as we can tell, bacteria aren't yet communicating with radio waves back and forth.
We haven't heard signals from
them. Very likely the universe could have bacteria all over the place, and we just wouldn't know it yet.
I mean, it's one of these ideas, right? This rare earth hypothesis that simple life could very well be everywhere, but more complicated life, like what we have here, the ones that are capable of operating radio telescopes, is the one that's incredibly rare and possibly even unique in the entire Milky Way.
Yeah, it's virtually certain that there is vastly more simple life than highly complex life in the universe. And so if bacteria tend to be a good pattern for simple life outside of planets like Earth, then bacteria very well may dominate the universe.
Yeah. Okay, so I want to just do a little bit of housekeeping here before we go and move into the sort of how do people find out more part. The first thing is, once again, as always, a big thank you to the WSH crew. These are the people who are really act as the producers of our show. They schedule our guests, and they maintain this really great relationship with us. We serve at their pleasure. So you can see sort of the chat that's happening down here, down at the bottom of the screen, and the way you participate in that is go to WSH-crew.net, and that's the community that's set up sort of around the Weekly Space Hangout, and they'll give you information on how you can join the Slack, which is the chat that's going on live during the show, which is different from the one that goes on the YouTube channel. The other thing that I want to let everybody know is we've been talking about the eclipse that's coming up next year, August 21st, 2017. The big one's going to be going right through the United States. And so myself and Pamela and perhaps some of the rest of our friends are all going to be showing up near where Pamela lives in St. Louis, and we've actually we're booking a hotel. We're going to get a bunch of buses. We're going to go hang out for about 3 days and try and chase the eclipse and do some live shows and just hang out with everybody. So if you want to experience the eclipse live, you want to hang out with me and Dr. Pamela Gay from Astronomy Cast and any of our other shows and things that we're going to be doing, go to astronomycast.com, and there's a link there to our events, and there's a link to the actual eclipse event. So check that out. I'm not sure how many tickets we have left. I think we've got a room for about 100 people. So my guesses are going to sell it pretty quick. But I think for all of you as special friends, I thought I'd let you guys know in advance before we widen the circles out. So check that out. All right, let's move on to where we give everyone a chance to let us know where we can find out more. So first, Morgan, where do we find out more?
I'm going to abuse my plugging privileges here to recommend that if you're interested by our, and I saw this in the chat, so thank you whoever put this in the chat and reminded me, if you were fascinated by our Mars discussion today, then you should certainly head down to your local book realtor and check out the books by Kim Stanley Robertson, Red Mars, Blue Mars, Green Mars, Red Mars, Green Mars, Blue Mars. I can't remember the order they go in. It's by far the most realistic depiction of how settlement of Mars might occur and addresses the very sorts of economic and political questions that Kimberly was saying would probably be the biggest hurdle to overcome. So some of the best science fiction books that I've ever read, they really can't recommend them more highly enough. And if you're excited by Musk, then these are right up your alley. Other than that, of course, you can follow me on Twitter at Morgan Renberg or visit my website, morganrenberg.com.
Apologies. I tried to get a lower third going for all of you guys, like what I've got down here, but my technology broke. So next week I'll have that figured out. All right. Kimberly, where do people find out more?
Well, people can always find out more by following me on Twitter at AstroKimCartier or visiting my website, KimberlyCartier.org. And if you happen to be in the central Pennsylvania area near Penn State in about 2 weeks, the Penn State Department of Astronomy and Astrophysics is hosting Astro Night, which is October 15th in the evening, which is a very exciting public outreach event with lots of demos and talks and such. A smaller version of our summer Astrofest. So if you're around, come out and hang out with us.
Fantastic. Yov Lansman, where do people find out more?
You can follow me on Twitter. I'm Masakritit. And if you can read Hebrew, then I also have a blog called Masakritit. And that's all.
Wonderful. All right, so thanks to everyone for joining us this week. Really appreciate it. Thanks. And I would love to hear from you in incredible detail, any feedback that you might have on this show, specifically sort of, from an engineering standpoint, from how the production went, because this is sort of the first time using this new software. I think it went a lot smoother, and also I'm solo, but like sound levels, were they okay? Was anything cutting out? Was there any drop frames? I would love to know if this is working for you, and then any other improvements that you'd like to see. So you can just always drop me an email. I'm frasercain@gmail.com. Just go ahead and drop me an email if you have any suggestions or feedback. Apart from that, we will see you all next week. And remember, join us in about 20 minutes if you want, and we're going to be recording our live episode of Astronomy Cast. You can get that then turns into the podcast, but we spend a lot more time and answer your questions and so on. So go ahead and do that. You can see that's going to be live streamed over on the Astronomy Cast YouTube channel. So I'm going to be heading over there in like 5 minutes. So thanks everyone for joining us this week. Elon, please don't break our hearts. See you, everyone.